This is problem 2 of homework 2, and we're going to follow the same process that I did for problem 1. So what I have here is the given data of time in minutes versus gallons collected, or volume collected in gallons. And I've generated 3 plots all on one sheet so we can look at this more easily. Clearly the semi-log graph is not linear, so it's whether the rectangular coordinates or the linear coordinates appear linear, or whether it's the log. Both of them do appear linear, but I think you'll agree that there is some bowing to this one, and this one is much more linear. And again, we could do a more statistical analysis on it, but this is the one that is linear on log, and therefore the data follows a power law. You'll notice too that I did not plot the first data set, so if I just highlight the data, it'll show that yes, I'm indeed plotting starting at 5 minutes, because 0, 0 cannot be plotted on log scale. So we could have plotted it on this one, we couldn't plot it on the semi-log or the log, because you can't plot 0 on those scales. So anyway, the data does follow a power law. That's saying when we do the analysis to get the least squares fit, we aren't going to take time versus volume, but actually our x and y are going to be log time and log volume. So the next spreadsheet you will see is I will have eliminated these 2 graphs and added some columns so that I can do my summing. Okay, now I have my spreadsheet expanded a little bit. Once again, I've just retained my log curve. I also changed the maximum on my y to 200 and my x to 600, just so I removed some white space. And then I created some columns so I could do my sums. So again, the x value is not going to be time, but it's going to be ln of time. And actually, again, we can't use this first point because you can't take the log of a negative number. So we're going to start this analysis at the first data point of 5. Whoops, I'm not sure what happened there. Okay. Then the y value is going to be the natural log of the volume. And then my x squared value, again, my x's are not time, but it's log time, so I'm going to square the values in column D. And then xy is going to be column D times column E. Alright, so now I have my 4 entries. I'm going to copy that down to the bottom, and that creates fills in my table. Let me just put a box around that. Then my sums is going to be the average, and I can't spell average of all this. And then again, I'm going to copy this over. Alright, so now I've got my sums, my 4 sums. Now I can go and calculate my slope. In this case, unlike problem 1, where I knew the intercept, problem 2 I don't, so I need to calculate both the slope and the intercept, and so let me enter that equation. If I look on my sheet, that's going to be G21 minus D21, oops, 21, not 22. I want to put in the number, not the symbol, minus D21 times E21, close parentheses, divided F21, oops, minus d21 squared. And my slope is 0.723, which is the reason it looked fairly linear on linear scale, because that slope is close to 1. Now that I have my slope, and now I can also calculate my intercept with using the formula that's on my sheet. So that's F21 times E21 minus G21 times D21 close parentheses divided by F21. Did that take F21? There we go. Minus D21 squared. Now again, that's my intercept, but that's not my A value. My intercept is log A, and therefore my intercept is going to be the exponential of A, or 5.341. This has no units, so I don't have to worry about anything past that, but this has units of gallons divided by minutes raised to 0.723. Now that I have A and B, I can go ahead and calculate the volume for each time. And to do that, I put in my power law. So that equals A times T raised to the B. Now, there's nothing wrong with this. However, when I copy it, all my numbers will get updated, and I don't want A and B to get updated. So I'm going to put dollar signs in front of the 26 and the 24. And that way, when I update, the only number that changes is the 9 after the B. So I can see this is now B10, B11, B12, and so on. And let me put a box around that. Okay, now I want to plot this. So I'm going to highlight the data, right click, select data, add a data set, and my X values are going to be in minutes, in minutes, and my Y values are time, are volume, but now it's the calculated volume. And OK, and OK. Now they're both on top of each other. You can't really see the difference, so I need to change that to a line. So I'm going to format. I'm going to make the marker options with none, and the line color with solid. And now I see I have a line representing the function and symbols representing the data. And that's finished.